Okay, now for part 2. Part 3, I'm sorry, part 3. Part 2, I mentioned macrophages destroying some of this stuff, which are part of your immune system. And this is a video I did in 2020 because of COVID stuff. And I broke down the immune system. It's on my channel. Why are they hiding your immune system? Part 1 and part 2. And here, let's just do a brief summary.
Immune system. You've got specific immunity, which is acquired immunity.
You got specific immunity, which is acquired immunity.
And then non-specific. Acquired involves antibodies. Non-specific doesn't even require those.
Yeah, so in your, like I said, antibodies, non-antibodies. I mentioned macrophages, so we're over here in the non-specific immunity.
Okay, we've got T cells and B cells. T cells are intracellular, cell-mediated immunity. B cells are extracellular, formation of antibodies.
Through either primary, secondary, or complement.
A form of humoral immunity in primary, secondary, and complement. Non-specific immunity involves, it should be an M. Non-specific immunity involves granulocytes. And macrophages. Granulocytes digest. Their neutrophils are 90%, basophils and mast cells 1%, and peripheral tissue, not the blood. Lung, mucosa, connective tissue, intestine, and blood vessels.
Macrophages.
Macrophages are activated by inflammation. Okay, you've got phagocytosis, which engulf the antigen. In this video, an antigen represents a virus, bacteria, toxin, whatever your body is fighting. ATC, macrophages involve ATC, antigen presenting cells. They have a piece of whatever it is, virus on there, and they present it to the specific immunity. Lymph, skin, spleen, thymus. The MHC codes for self, so that your body doesn't attack itself. And MHC produces interleukin 1. Interleukin 1 is what causes a fever. And then we've got the classic pathway. We've got the complement system that really just magnifies these. And you've got classic pathway, alternative pathway that I'll get to in a minute. But first,
yeah, so, okay. And as I said, graphene oxide sheets could adhere and wrap around cell membranes and insert in lipid bilayers or be internalized into cell. In the hydrophobic graphitic domains with cell membrane. Results prolonged exposure to or high concentration of graphene induces physical or biological damage to cell membrane and destabilization of actin filaments in cytoskeleton. Graphene oxide sheets interact with plasma protein sheets and are phagocytosed by macrophages. Macrophages undergo morphological changes upon contact with graphene oxide, cause depletion of mitochondrial membrane potential and by triggering apoptosis, which is cell death. And I've got this was with the article here. This is with the article. And you've got cell membrane damage. There's graphene oxide going through the cell membrane. Here it is, endosome. Cytokine release, inflammation response, endoplasmic reticulum, intracellular calcium flux, mitochondrial disorder, you know, on and on, but I'll leave this up here. Well, toxicity in organs. So many studies show toxicity, and we'll focus on graphene oxide can result in acute inflammation response and chronic injury. We're going to get to this good part. By interfering with normal functions of organs. Oral route shows no absorption of graphene oxide through gastrointestinal tract. But here we go. Now here's a low dose of graphene oxide caused serious injury to gastrointestinal tract after mice drank a graphene oxide low dose because low without agglomeration can easily attach to gastrointestinal surface and cause destruction by sharp edges. So this is, I saw this video a while back about somewhere in another country, this doctor had disappeared, ended up dead, and he was speaking out saying that graphene oxide destroyed it through sharp edges, and I thought, oh, this must be a kook maybe. And here it is. I saw it here and somewhere else mentioning sharp edges. And here's our structure, and I guess these are sharp edges. Okay, intratracheal installation, by the through the throat, they test this through oral stuff, cause inflammation and stayed in lung on day 90. Regular nose inhalation translocated to lung lymph nodes. High dose forming aggregations can block pulmonary blood vessels, results in dyspnea, which is shortness of breath, platelet thrombi. Okay, surface structure causing damage. Graphene is hydrophobic. Graphene oxide partly hydrophobic with carboxylic groups, as I said. Graphene nanoparticles disrupt the function and structure of cell membranes and proteins, probably by really strong molecular interactions with cells, like I showed you. Bonds to cell membranes, stimulated receptors, and activated mitochondrial pathways involving apoptosis, cell death. Graphene oxide is smaller and less toxic than reduced graphene oxide due to high oxygen content, smoother edges, and hydrophilic properties. Graphene oxide can insert between base pairs. Now get this. In that video earlier I showed you of that guy that was investigating funeral homes, he mentioned possible damage in the RNA producing proteins. Well, here it is. Graphene oxide can insert between base pairs of double-stranded DNA and disturb flow of genetic material, which is cause of its mutagenic effects. The charge. Graphene oxide particles cause changes in lysis, leading to high hemolysis, which I already told you this, in blood cells. Red blood cell membrane disruption is probably attributed to strong electrostatic forces between the charge, oxygen groups on graphene oxide, and positive charge on the phosphatidylcholine lipids. I showed you that already. Impurities. Traditional prepared graphene oxide contains high levels of manganese and iron, which are highly mutagenic cells. leads to cytotoxicity and DNA fractures. Protein coronas. Okay, we're going to get to some more. It's a coating of biomolecules like proteins around the surface of the nanoparticle. So they can coat them, these graphene, they can coat them with different surfaces. Due to high free surface charge, nano can easily form coronas with proteins, and this changes its circulation, distribution, clearance, and toxicity. Reactions with proteins in serum. Graphene oxide coronas can regulate the adhesion of graphene oxide to endothelial and immune cells through both specific and non-specific interactions. Immunoglobulin G and complement proteins in the protein corona help to reorganize nanoparticles in immune cells, causing particles to be engulfed by RAS and IgG. And that is we go back over here, that's the classic pathway of antibodies. Pristine graphene adhered in surface cells and resulted in abnormal stretching of cell membrane. Further, the sharpened edges, here we are again, of graphene oxide may act as blades, inserting and cutting through bacterial wall membranes. Also, graphene oxide damaged the outer membranes of E. coli, resulting in release of intracellular components. But coating graphene oxide prevents that. Oh, so now here's another question. Here's a theory I have. You've got healthy bacteria in your gut. Are they perforating those too? ROS leading to oxidative stress. When increased levels of ROS overwhelm the activity of antioxidant enzymes like catalysts, graphene oxide interactions with cells can lead to excessive ROS, which is a first step in carcinogenesis, aging, mutagenesis, oxidative stress. Oxidative stress had a significant role in graphene oxide-induced acute lung injury and the inflammatory responses caused by oxidative stress emerged upon exposure. And oxidative stress was key cause of apoptosis and DNA damage. Mitochondrial damage. Mitochondria is a powerhouse of the cell and functions to generate energy. It's the energy cells. Generate ATP, energy currency of the cell. Also involved in apoptosis. ATP is formed by citric acid cycle. Mitochondria converts chemical energy from food to an energy form the cell can use, which equals oxidative phosphorylation. Cycle makes NADP, which is used by enzymes in cristae to form ATP. ATP is double bonds. When bonds break, energy can be used. Reactive oxygen species are produced in mitochondria as a byproduct of energy production. Exposure to graphene oxide nanoparticles results in significant increase in mitochondrial oxygen consumption, dissipation in mitochondria membrane potential, and triggering of apoptosis, triggering of cell death by activating the mitochondrial pathway, accelerating the generation of ROS during mitochondrial respiration. An MHS cell system could enhance oxidation and thermal stress to impair mitochondrial respiration system and eventually result in dramatic toxicity. DNA damage due to small size, surface area, and charge. Graphene oxide may possess properties to cause severe DNA damage. Now, inflammatory. Here we go. This is a good part. like inflammatory cell infiltration, pulmonary edema, and granuloma by IV or intratracheal instillation. So, you can get pulmonary edema, which is what, as I recall, a lot of people that had a vaccine had pulmonary edema. Platelets are important components in clot formation to attack pathogens during inflammatory response, and graphene oxide could directly activate platelet-rich thrombi formation and occlude lung vessels after IV injection. A strong inflammatory response was induced by subcutaneously injection of graphene oxide for 21 days along with cytokines. Apoptosis, the cell death, is graphene oxide cause apoptosis and inflammation in mice lungs after inhalation. Graphene physically damaged cell membranes. Now, reproductive damage. Graphene causes very little or no toxic effects in male reproduction, even with high dose. But mouse dams. Now, even high dose via intra-abdominal injection, mouse dams could give birth to healthy offspring after graphene oxide injections before mating or early gestation, and only a few abnormal fetuses. However, the pregnant mice had abortions at all doses, and most pregnant mice died. When high-dose graphene oxide was injected during the late gestation. So, any mouse dam that was injected during late gestation, all the mice, all the embryos died. High-dose graphene oxide decreases maternal mice's water intake consumption by oral exposure, which decreases milk production. Lung injury induced by graphene oxide, inflammatory cell infiltration, pulmonary edema, and granuloma formation in lungs. So we've got, as a summary, pulmonary edema, cell death, sharp edges, damaging gastrointestinal tract, through reactions with cell membranes. You've got, like I said, I thought the sodium oxide, something in a long compound. You've got these strange white clots that doctors have never seen before. I mean, the very idea to go into your cell like this and cause cell death. I mean, this stuff, and this article was in 2016. 2016. So they knew full well what this crap would do. So I'm going to end there.